So this exercise is related to equilibrium constant Kc and Kp. You can use a chat to state the answer. The first question. The equation for manufacture of ethanol by reaction of ethene and steam, which is with a catalyst phosphoric 5 acid is used. The total enthalpy change is negative, which means the reaction is exothermic. The highest equilibrium yield, like which condition the reversible reaction is exothermic. And remember, increase in pressure shift the equilibrium towards side where number of moles of gas are few or less. So we have the reactant which are having a high energy and the product is having low energy. Which conditions will increase the amount of ethanol? So C2H4 plus H2O, C2H5OH. Means we want the equilibrium to shift towards the right hand side. So which conditions will shift the equilibrium towards the right hand side? The temperature, what is the change in temperature, and which one is the change in pressure. The correct answer for this one is C, because for exothermic reactions, if we lower the temperature, it will shift the equilibrium towards the right hand side. And if we increase the pressure, the equilibrium will shift towards side where number of moles are less. So in the reactive side, we have only 2 moles. In the product side, we have 1 mole. That's why it causes the equilibrium to shift towards right hand side. Option C is the right answer. Question 1, part B, the units of Kc. So first you should write the equation, the expression for Kc. The Kc expression will be, Kc is a product divided by reactant. So we have ethanol for concentration C2H5OH divided by C2H4 NH2. And this is a homogeneous equilibrium because all of them are in the same state. And remember, the unit of the concentration is mole per dm. So this is mole per decimeter cube. This will be mole per decimeter cube. This is also moles per decimeter cube. So when we simplify, what's the final answer? The question 1. Part B. So B will be the right one because mole per dm cube will cancel with mole per dm cube. This will move in numerator, like in this case, is equals to 1 divided by mole per decimeter. When we simplify, it will be dm cube divided by mole, and then mole will move in numerator. So it will be dm cube mole inverse. That's why B is the right answer. The equilibrium constant for this reaction increases when, remember, the pressure does not have any effect, the catalyst does not have any effect, the change in concentration does not have any effect. So what we are left with, we are left with only option. You see that when we decrease the temperature, the equilibrium constant will increase. Because it's an exothermic reaction. For exothermic reaction, decrease in temperature, increase the value for Kc. Now this is a heterogeneous equation in which we have different states of the reactant product. The reactants are in solid, the product is solid and gas. So we don't include, because in heterogeneous equilibrium, we don't include a solid or a liquid. So when we write Kc or a Kp, so that will be only the pressure of the gas, pressure of oxygen, and that raised to power 1 by 2. Why 1 by 2? Because the coefficient here is half, that's why that will be the power 1 by 2. So it matches with option C. So it is important whenever you see the equation, you have to check the states of the reactant and product and identify whether it is a homogeneous or a heterogeneous equilibrium. In question 3, dinitrogen tetroxide forms an equilibrium mixture with nitrogen dioxide. At equilibrium, when the temperature is 400 Kelvin, the equilibrium partial pressures are shown. As you can see, the partial pressure, the numerical value of a Kp. So first we write the expression for a Kp. So Kp is equals to the pressure of product, which is nitrogen dioxide, and then square. Why? Because that is the coefficient here, divided by the concentration of dinitrogen tetroxide, the pressure of dinitrogen tetroxide, N2O4. Now we substitute equilibrium partial pressures are given. So the partial pressure of NO2 is given 4.18. So 4.18 square will be there. And the partial pressure of N2O4 is given 0.365. So 0.365. So when we substitute, it will give us 47.9. And the unit, what about the unit? How to work out? Because unit of the pressure is ATM here. So the numerator is ATM square and denominator is ATM. So this will simplify. We are left with only ATM. So it will be 47.9 ATM. But again, it may have a different units. Like it may be ATM square, it may be ATM -1, -2, depending on the type of equation. Or it may sometimes does not have a unit as the two cancel out each other. In question 4, the equation for equilibrium between the nitrogen and oxygen may be written in two ways. Like we can write N2 plus O2 gives 2 NO, or we can write half N2 plus half O2 gives 1 NO. The equilibrium constant K1 and K2 are there. The standard enthalpy change is 180 kilojoule per mole. For the first reaction, means the first reaction, the enthalpy change is 180 kilojoule for 1 mole. So the question is, what will be the enthalpy change for the second reaction? The overall enthalpy change is there as 1 mole of nitrogen, 1 mole of oxygen gives 2 moles of nitrogen dioxide. But here what happened? Half mole of a nitrogen, half mole of oxygen give 1 mole of nitrogen oxide. So what will be the enthalpy change? For this reaction, so it will be half of it, because here 2 moles are there and now we have only 1 mole. So it will be 90 kilojoule per mole. So what is the standard enthalpy change of a reaction as shown in the second? This will be plus 90. As the equation, we are not using this, like the first we were using 1 mole, and now we are using half of mole. So enthalpy change will also be half. Then equilibrium mole fraction of NO is increased. If we increase the mole fraction of NO, where the equilibrium, like the mole fraction of NO is increased by. So how we can increase the mole fraction of NO, or how we can shift the equilibrium towards the right hand side? And we know the reaction is endothermic. Forward reaction. So if it's an endothermic reaction, we should increase the temperature, should we shift the equilibrium towards the right hand side. Or about the pressure does not have any effect on this. Why? Because 1, 1 and 2, or here half of, which will make 1 and 1. So if the number of moles of gas or gaseous reactant product are same on both sides, there is no effect of the pressure. So this will, the equilibrium is not affected by change in pressure for this example. So if we change the total pressure, it is not affecting the equilibrium. Either increase temperature or decrease. But because the reaction is endothermic, as they mentioned in the beginning, that enthalpy change was plus 180. So increase it means it is an endothermic reaction. For endothermic reaction, equilibrium is shifted towards the right hand side if you increase temperature, which will favor the forward reaction. Then which of the following expressions is correct? So when we compare Kc1 and Kc2, which of them is the right answer? the comparison. So these type of questions are also common. The simple way to solve these such type of question is write a Kc for both of them. Like the first reaction, the Kc is K1, and the second reaction, Kc is K2, equilibrium constant. So equilibrium constant for first reaction is NO square divided by into O2. And for second expression, it is NO divided by N2 raised to power half and O2 raised to power half. How I can make the right hand, because I want to compare the two equations, so I can make the right hand side same for them. Here it is NO. So if I square this equation both sides, so it will be left hand side will be equal to, like the right hand side for two equations will be same. So it will become NO divided by N2 plus O2. So I can compare, I can say that K1, because now the right hand side of the equations are same, so I can compare left hand side. So K1 is equals to K2 square. So K1 equals to K2 square. So which expression K1 equal to K2 square, or I can also say under root K1 or half K1 is equals to K2. If I take a square root. So K1 is equals to K2 square. K1 equal to K2 square, this is given. I can say, or if there was an expression that under root K1 or half K1, K1 raised to the half is equals to K2, that will also be right. But there's no expression like this, only C is the right one. In question 5, the equations for a synthesis of methanol is given. The equilibrium moles are there. How to work out the mole fraction? To get the mole fraction, the moles divided by total. So to get the moles of hydrogen, the moles of hydrogen 0.32 divided by sum of all the moles, that is 0.51 plus 0.32 plus 0.18. This will give us 0.65. So 0.32 divided by 0.65 will give us 0.49. So the mole fraction for hydrogen is equals to 0.49. So C will be the right answer. So to get the mole fraction, the moles of that reagent divided by the sum of all the moles. The next, the numerical value of the partial pressure of a carbon monoxide in atmosphere. So if the total pressure, how to get the partial pressure? The mole fraction multiplied by total pressure, like the mole fraction is there. If I want to find the carbon monoxide, that is the moles of carbon monoxide divided by sum of the moles, which is 0.65, and that this is called a mole fraction multiplied by total pressure. So total pressure is 20, so we multiplied by 20. So 0.15 divided by 0.65 into 20, or 0.23, because this value is 0.23. So 0.23 multiplied by 20 will give us the partial pressure of carbon monoxide. That will be 4.6. Then use the equilibrium constant, units of the equilibrium constant. So how to work out the unit of equilibrium constant? Kp. First we'll write the expression for this. Kp is the product divided by reactant. So pressure of methanol divided by pressure of carbon monoxide. You can write, instead of writing as a prefix, you can write in this manner, and then the pressure of hydrogen square. The unit of pressure is ATM. This will be ATM, this will be ATM, and this will be ATM square. This will cancel. So 1 over ATM square. When we move in numerator, it will be ATM raised to power minus 2. So the option which is having ATM raised to power minus 2 is the right. So option D is the right. In question 6, the reaction between carbon monoxide and hydrogen reaches a dynamic equilibrium. Dynamic equilibrium means when rate of the forward reaction equal to rate of backward reaction and there is no change in the concentration. So which statement about a dynamic equilibrium is not true? The forward reaction, the forward rate is equals to backward, that's true. The concentration of the product and reactant do not change, that's also true. The concentration of product and reactant are equal, that is wrong. Because that the concentrations are not equal, like it's not like 2 mole per dm cube here and 2 mole per dm cube here. That's wrong. They may have a different concentration, but their rates are equal. And equilibrium can be approached by either direction. That's true. Like if I start with a reactant or I start with a product, I can reach the equilibrium. So equilibrium is not affected by whether we started with reactant or a product. So that's why C is not the right statement, or C is the right answer. Then Kc expression for the above reaction. So that is a product divided by reactant. So this will be the expression for Kc, the product divided by reactant. So Ca will be the right answer. Then the hydrogen and iodine, both with initial concentration of 0.1, were allowed to react at equilibrium. Hydrogen iodide was 0.003. Calculate the value for Kc. Kc is calculated using the values. So what will be the concentration of iodine, hydrogen, and hydrogen iodide at equilibrium? Look, initially we were having 0.01, 0.01, and this was 0. But at equilibrium we have 0.003. So first we'll find how much hydrogen reacted. And then we'll subtract from the initial one the relation between hydrogen and hydrogen iodide. The ratio is 1:2. So if it is 0.006, then 0.003, then this will be x. Cross multiply. So 0.003 divided by 2, that is 0. So how much hydrogen reacted? 0.0015 reacted. But we don't need how much reacted, we want how much left at equilibrium for the initial. So at equilibrium, this will subtract 0.01 minus 0.0015. 0.01 minus 0.0015, that will give us 0.0085. So 0.0085. So this is the concentration of hydrogen we should use. What about iodine? The same way we will solve. If this was iodine, the ratio between them is also 1:2. So same number of moles of iodine and same subtract, so 0.0085. So 0.0085, 0.0085, and 0.003. That's why D will be the right answer for this. So the idea, whenever we use the concentration, we always use this concentration at equilibrium. Question 8. The reaction below reached dynamic equilibrium. The concentration at equilibrium are there, the Kc for this reaction. So it is a product divided by reactant. So Kc or Kp. The concentration of R, concentration of S divided by concentration of P and concentration of Q. So we have all the concentration at equilibrium. We'll just substitute and get the value for Kc, which will come out as point. We just substitute the values which are given here. In question 9, the Haber process, which is used to manufacture ammonia for nitrogen and hydrogen at 450. The forward reaction is exothermic. If the partial pressure of these gases are measured in atm, what is the equilibrium constant Kp will be? So when we write Kp, that will be a pressure of ammonia square, the partial pressure of nitrogen, and the partial pressure of hydrogen, which is called. This will be ATM square, this will be ATM, this will be ATM. Simplify square, this will cancel, so we are left with 1 over ATM square. This will move in numerator, ATM minus 2, so C will be the right answer for us. When the temperature of a system increases, what happens? Because the forward reaction is exothermic. Exothermic reactions, if we increase the temperature, the equilibrium, the value of the Kp will decrease. So A will be the right answer. Kc and Kp is only affected by changing temperature. What are the units for Kc for the following? So Kc they are asking, not Kp, so we don't, A and B cannot be an answer. So when we write the expression for Kc, this sulfur trioxide concentration, when you write concentration, you should use a square brackets because we represent the concentration by square brackets. This will be mole per dm cube square. This is mole per dm cube square. This is mole per dm cube. This will cancel, so we are left with 1 over mole per decimeter cube. This will go there in numerator by itself, so it will be dm cube divided by mole. And when mole will go there in numerator, because it's power 1, it changes to minus 1. So dm cube mole minus 1. So C will be the right answer. So these are some questions related to the Kc and Kp.